So hello, people at home. Okay, so I did want to start off just by reviewing these because what we're doing today is going to be using some of each of these topics we learned in the past. For all of these here, these are all what type of problem? Multiplication. So when we're multiplying negatives, there's two rules we needed to know. The first one is if you're multiplying a negative and a positive, it's always going to be a negative, and then a negative times a negative. Perfect. So something like negative 10 times negative 2 gives us
negative 20.
Negative 20 because
It's 10 times 2.
Gives us 20.
And then positive 20.
And then a negative times negative gives us positive. Perfect. For combining like terms, yesterday we learned that in order to combine something, to put them together, they need two things in common. Do you remember what the two things are?
Variable and an exponent.
Ooh, look at that math vocabulary. They need the same variable or the same letter, and then the same exponent, so that tiny little number there. So for example, this last one here, if I'm looking at this, what are two things we can combine?
6y, negative 5y.
And I love how you include that sign with the 5y. So 6y minus 5y?
Y.
So you're going to say 1y, but then you changed it just to y. Why? Too many y's. You were going to say 1y, but then you changed it to y.
Right.
Why is that?
Because you don't need the 1.
Perfect. We learned, like up here, if you don't see a number.
It's 1.
Perfect. So that gives us y, and then
3 plus 2 gives you, sorry, so it'll be y plus 5.
y plus 5. Is there another way we could have written that?
5 plus y.
Ooh, yeah. So the other thing we had talked about yesterday is the order you put those does not matter, as long as the signs are the same in both of them. Nice. We learned yesterday combining like terms because it helps you simplify problems, right? I took a problem like this that had 4 terms, and you were able to get it down to 2 terms. There is another way you can simplify these problems with variables in it, and that way is using something called distributing. So our objective is going to say I can simplify. So we're still trying to make things simpler, but this time we're going to use a different way. We're going to talk about simplifying by distributing. Have you heard the word distribute before?
Yeah, this is when you pass out stuff.
Yeah, that's always the example I use. So if I had, for example, like all these papers, and I wanted to pass them out, I could say, I'm going to distribute these papers to all of you. There's a math definition to it too, and that's what we're going to look at today. In order to help us talk about what distribute means in math, I've got this problem right here, and we're going to talk about 2 different ways to solve it. I've given stuff like this to you in the past, and what would you use to help you simplify this? Perfect. So order of operations, if we're using PEMDAS to tell us how to do this math, what would you want to do first?
The parentheses.
Yep, P is for parentheses, so we would do that and get
9.
Then what?
Then you would multiply the 2 with the 9.
Yep. So I'm just bringing down that 2, bringing down those parentheses because they're telling me multiplication, and then we could do the 2 times the 9, which gives us
18.
Perfect. We learned this because this is going to help you do any sort of math problem like this where there's multiple operations. There's multiple math things you need to do. However, there is a different way to do this problem. Do you know what the other way is? Sometimes people know and sometimes people don't. So this right here, remember those parentheses mean like all of this is together, right? So this is saying 2 times all of this. So one way you can do that is figuring out what all of this is first and then multiplying. But if this says 2 times everything, the other way you could do it is multiply 2 by everything. Now what would that actually look like us doing?
2 times 3 plus
Yep.
6.
Yep, the 2 times the 3 gives us 6. 6, okay, so the 2 times the 6 is the same thing as 6 plus 6, which is 2 times 6?
12.
12. So we're saying, let me get rid of my little lines for a second. This says 2 times everything, so let's multiply 2 by everything. Let's multiply 2 times the 3, multiply the 2 times the 6, and then 6 plus 12.
18.
Oh, what do you notice? Same answer. Why am I doing this to you? Why? You got so good at order of operations. You know that way works. Why am I showing you a different way? Do you have an idea why? It has to do with what we've been looking at this week with variables. If I were to change this problem just a little bit, so let's say instead of 2 times 3 plus 6, let's say it was 2 times 3 plus x. All our problems yesterday had variables in them, right? Mm-hmm. Problems today are going to have variables too. If we had something like this, if I tried using order of operations, if I tried starting inside the parentheses, can you add 3 and x together?
You can, but it would just be 4.
Go back to what you told me during our do now. In order to combine things, what do they have to have in common?
Same variable and exponent.
Same variable and same exponent. So can I combine these? No, they don't have the same.
Variable.
Yep, or really exponent. they don't have what they need to have in order to combine them. This is an x. This is a number. They're not the same. So I could not start in the parentheses. I could not use this way if we had a variable. However, distributing, you can still do that because you could multiply that 2 by anything you want. So the reason we're learning this way is specifically because this is going to be what we have to do when we've got variables in it. However, everything you learned before is still true. I'm not taking this away from you. I would say if the problem has numbers, if it's all numbers, multiple operations like this, keep using this. Know that this is also an option now if you want. But the reason, like I asked earlier, I was like, why am I doing this to you? The reason is because we're going to need it to help us simplify these problems with variables in them. So, the second way we're learning today is called distributing. Before I erase that, you had said earlier you think of distribute with this idea of like passing something out to everyone. It's like passing out this 2 to everything. You're multiplying the 2 with the 3, you're multiplying the 2 with the 6. The 2 is getting distributed to all the things in your parentheses. So in math, we say distribute is this process where you multiply a term outside the parentheses to everything inside the parentheses. So that one we were looking at was 2, I think this was it. You're multiplying that 2, that term outside the parentheses, to everything inside the parentheses. You can hear the word distribute for this. You can hear distributing. I think that's the word I used in the objective. You can hear distribution. In math, the rule that says like this is an okay thing to do, this mathematically is a legal thing, the rule is called the distributive property. They all are talking about the same thing. I want to make sure you're hearing all the different words because maybe you have a future math teacher who says, I'll say like, let's distribute, but maybe a future math teacher says, let's use the distributive property. They're all talking about the same thing. Distribute. But in math, we've got different rules that say like, this is legal. And the name of this math rule is distributive property. Now that we've got the vocabulary, let's distribute. We've got these first 2 examples to look at. Using what we've been talking about, what do you think I need to do for this first one?
Multiply the 5 by the 2 and the 3.
Love it. Multiply the 5 by the 2 and multiply the 5 by the 3. These lines look silly to you. If they look silly to you, that's fine. I found that they help help a lot of people. Just remember what you've got to do. So you said we're going to multiply the 5 with the 2. That's going to give us
10.
Yep. What do you think I'm going to write down?
10x.
Nice. So if there's a variable with it, you do exactly what you just said. Multiply those numbers and then just bring down your variable. And then you said, what else do you want to do?
Multiply 5 by 3, you
Yeah.
get 15.
Perfect. Anything else you want to
No,
do? Why not?
because there's no, they're not the same, there's no x behind the 15.
Beautiful. So sometimes people want to say, oh yeah, 10 plus 15, 25x. But you got it exactly right. This one's got a variable, this one doesn't, so we can't combine. We can say they're not like terms. Like terms are those things you can combine, so these are not that. They're not like terms. That means that this right here is our final answer. You want to try one more?
4 times x is 4. And 1 times 4 is 4.
Mm-hmm.
4 minus 4, that'd be 4x.
All right. For x minus 4. Nice.
That's as far as you can go.
That is as far as you can go. Talk me through, how did you get 4 times x is 4x?
Because an x by itself is just 1.
Mm-hmm. An x by itself, yeah, it has a 1 in front of it. So we're really just thinking 4 times 1 to give us that 4. You didn't forget that x, which is good. And then the same thing here. How are you feeling about these?
Good.
It's just, I think it's just a lot of multiplying. You just got to know what to multiply. There are 3 for you to try if you want to do those on your paper. I think. Oh, I don't like this. My last one is different. Give me just a second. I think I've got the wrong PowerPoint. Oh, did I open that one? Which one are we using right now? Is this the... okay, here we go. Isn't... Okay. I had an old PowerPoint. But now we're good. Okay. Let me have you talk through this last one for me.
So 6 times 2x would be 12x.
Mm-hmm.
And then 6 times y would be 6. 6 times 10 would be 60.
Mm-hmm.
It would be 12x plus 6
You are like 90% of the way there. There's something missing.
6y.
There you go. Yep. I think that is one of the most common mistakes. Do you know what the other mistake is that I see a lot? It's only multiplying one of them and not the other, which is what I I know it looks like I'm drawing little rainbows on the paper, but if you ever catch yourself forgetting to multiply that second one, I think doing this is going to be an easy way to help. Real quick, tell me the other two. This one here is
20 plus 5x
mm-hmm.
and 9t plus 30.
90
9t minus 30.
minus 30. Perfect. Okay. So I think you figured it out. Today is just going to be a lot of multiplication. There are a couple things that can come up, and that has to do with if this number here is a negative number. Before we look at any of this, remind me real quick, there's two rules we said earlier. When you're multiplying a negative and a positive,
It's a negative.
mm-hmm. It's a negative every single time, and then a negative times a negative, positive, always positive. Perfect. We're going to use those rules to help us do these problems here. This first one here, the same idea. I see a number outside my parentheses. I can simplify by distributing. So we're going to start off by doing
Negative 4 times x.
Yep. That's going to leave us with
Negative 4
mm-hmm.
x.
Yep. These ones that don't have a number are almost easier because all you've got to do each time is put the number and the variable next to each other. Now the second part, we want to do
Negative 4 times 5.
Yep. So negative 4 times a positive 5.
Negative 15. Negative 20.
Negative 20. 5, 10, 15, 20. And then you get the negative. You just told me negative 20. So I'm going to write exactly what you told me. I'm going to write negative 20. So notice something happened here that's different than the previous ones. That sign right there changed. To get the sign in between your terms, just multiply the signs up here in the problem. It's not always going to be copying down what you see. This can change if you end up with a negative when you multiply, or it can change from a minus sign to a positive if you end up with a positive. That's what the note down here says. Make sure you're distributing the sign and the number. It helps some people sometimes to break it up into parts. So for that negative 20, the first thing I heard you say, which maybe you're already doing this, I heard you say negative first before you said any number. You can always start by just saying, well, a negative times a positive is a negative. And then do 4 times 5 gives you 20. You can make it into like little pieces. So one more, talk me through this one.
Okay, so negative 2 times 2 is negative 4.
Mm-hmm.
Negative 2 times negative 3 is 6c. But it would be plus.
Why would it be plus?
Because the sign there's a negative with a 2 and a 3.
Yep. So that negative times negative gives us a positive there. Nice, you've got it. How are you feeling about these? It'll be good practice for doing math with negatives. I told you all last quarter those negatives aren't going away. But the good news is if there's so many people I know who aren't 100% confident on them still, which is totally okay, today is a great day to practice. So you've got these three. I'm going to have you go ahead and try those. Uh-huh. Will you try it for me? We're definitely going to talk through that last one. But I agree, that last one's special. Let me see what you got. Okay, so let's talk through. Let me put some answers up for the first two here. This first one here, you got
Negative 15
mm-hmm.
plus 6m.
Mm-hmm. And then this one?
Negative 10y, negative 20z.
Beautiful. Now this last one. I saw the face you made. The face was warranted. It looks weird. Why does this one look weird?
Because there's no number in front of the 50% negative sign.
Right. So tell me what you did.
Added 3x plus 9.
Mm-hmm. So you said 3x plus 9. Let's add those together. Can we?
Not really.
Why can't we add those together?
Because they're not the same.
Mm-hmm.
Exponent.
Not exponent.
Variable.
Variable. Yep. They don't have the same variable. They're not like terms, anything like that. Let's go back to what you first said. You said it looks weird because there's no number in front of the parentheses. There is something in front though.
Negative sign.
Mm-hmm. So if we're doing the same thing for all of these problems, I see a negative sign in front. What can I do with that negative sign? What did you do with the negative 3?
I times it by the negative 5.
Yep. So what's that math word we learned? You.
Distribute.
Yep. So you distributed the negative 3 by multiplying it with everything. Here you distributed the negative 10 by multiplying it with everything. Here.
The negative with the...
Yeah. What is that going to give us?
0.
A negative times a positive?
Is a negative.
Mm-hmm. So we get negative.
3x.
Mm-hmm. And then...
Negative 9.
Yep. Negative. Ooh, that was a weird negative sign. Negative 9. There's no number, but there's still a sign. You can distribute that negative sign. That is one way you can think of it. The other way is if I wrote negative x down, what's that number in front of x?
1.
The whole number in front of x.
Number?
So you said there's a 1 here, which means the number in front is
1x. Negative 1.
There you go. Negative 1. You can think of that way here too. We don't see a number. So just like this, how you knew there was a 1 there, you can fill in that 1 if you want, and then multiply by negative 1. So negative 1 times 3.
Negative 3.
Negative 1 times 9.
Negative 9.
So it's a preference. If you want to think of it just as like multiplying a negative sign, you can do that. Or you can think of it as distributing the number negative 1. It's up to you. And it is up to you, people at home. But that one definitely can be tricky. Are we feeling okay with that now? Okay. I'm going to have to clean this board after. Okay. So, the final part to this is going to be looking at math problems, math expressions like these. Looking at this first one here, tell me just what you notice about it.
There's a number in front of the parentheses and behind it.
And behind it. Okay. So let's start with this number in front of the parentheses. What does this part mean?
I'm going to multiply inside the parentheses.
Yep. And the word I heard you say, we're going to multiply inside the parentheses. So what are we, tell me exactly what we need to do now.
9 times 2x is 18x.
Mm-hmm.
And 9 times 2 is 18.
Okay.
And then plus 3.
Why am I just writing plus 3? Why aren't we going multiplication crazy and multiplying those?
Because it would be the same.
Why?
It's not inside the parentheses.
It's not inside the parentheses. Remember, if we go back to like what we said at the very beginning, this is saying 9 times all of this. If I wanted to multiply the 3, what would it have to look like? So let's change the problem a little bit. What would I want to write? We could start off 9.
9 parentheses times 2x plus 2 plus 3 and then parentheses.
You got it. Look, you're being a math teacher. Yep. If it looked like this, we'd be multiplying all 3, but since that 3 you said was outside, it doesn't get multiplied. So our problem is this one here. We've got 18x plus 18 plus 3. Anything else?
Nope.
Why not?
They're not the same exponents. Well, variables.
Not the same variable. There's nothing we can do?
Maybe it's 18 plus 3.
Yeah. They are both numbers. So if you're thinking like same variable, same exponent, they don't have a variable, which makes them the same. So we could say 18 plus 3.
21. So 18x plus 21.
18x plus 21. Nice. Anything else?
Nope.
No, we can't because they're not like terms. They both don't have variables. So I want to summarize what we just did. In this problem here, what is the first thing you did?
Multiply.
Nice. We started off by multiplying. What's that math word we learned today?
Distributive.
Yep. So we started off by distributing, which just means multiply, right? And then after we distributed, what did we do then?
We added.
Do you remember the math word from yesterday?
Combined.
Combine
Like
terms, which you're right, it's just adding or subtracting things. So notice the steps we did. We multiplied first, and then we added and subtracted. Where have you heard that before? This idea of multiplying first, then adding and subtracting.
What I remember just here.
Here? A lesson, perhaps?
Yeah.
What lesson did we learn?
PINDOT.
Yeah, there you go. Look, it's just going back to this. Even though this was specifically for numbers, it's true here too with variables. We're doing the multiplication first before adding and subtracting. It was true in this problem. It's also true for any problem. You're going to have to distribute first and then combine like terms because it's going back to our favorite thing, PEMDAS. So in this problem here, using what you just told me, what do we want to do first?
First, you want to multiply the 2 times 9y, which would give you 18y.
Yep. Well, I'm going to just pause there and celebrate because you did not tell me to do 5 minus 2. When I tell you, people see this and they're just dying to write that 3 down. We can't do that because that's subtracting before you do the multiplication. Now, you said we want to multiply the 2. Look very closely. What is that number in front of the parentheses?
9y.
In front of the parentheses. Not just 2.
Negative 2.
Yeah. So we want to distribute that negative 2. So you said negative 2 times 9y.
Negative 18y.
Yep. And
Negative 2 times 18 is negative, times 8 is negative 16.
yep. What about that 5?
That'll be 5 minus 18y.
Yeah.
Negative 18y minus negative 16.
Yep, you got it. Same thing we did here where we just brought it down. Same idea here, bring it down. Anything else you want to do with this problem?
You can subtract negative 16. We'll add negative 16 from 5.
Mm-hmm. And I like how you're including that negative sign with it. 5 minus 16.
Negative 14.
Not 14. I like the negative, but not 14. If you're getting 14, I think you've got the right idea. You want to subtract these, but what's 16 minus 5?
Minus 5 is negative 11.
There we go. So we get our negative 11.
Minus 18y.
Yeah. Anything else you want to do?
No.
Good. I didn't trick you. They're different. They're not like terms. They don't have the same variable. So we are all good to go. Depending on like the steps you're doing these in, someone might have written something else. What's the other thing someone might have had written?
Negative 18y and negative 11.
Nice. Are they both okay?
Yes.
Carlos isn't here to tell us one looks more clean than the other, but they both are okay. How are you feeling about this one here?
All right.
I think you're doing great. All right, that leads us into the practice ones for that. You've got those 3 there to try. Peek in and see. Uh-huh. Okay. This one's good. This one's looking good so far. Is there anything else you want to do for that one? This one here, will you talk me through what you're doing?
First multiplying a and then 5, which gave me 6a plus 30.
Now read through that again, because you got something a little different. You've got, what are we multiplying?
Negative 6a plus negative 30 plus 10a. And it gave me 6a.
Oop, read again what you got.
Negative 6a plus 10a gave me negative 16a.
That's the math we want to check again.
Okay. 4a
Yep.
plus 30.
I'm going to show you something, because we've been talking a lot about how you can, it doesn't matter the order you're looking at stuff. So when you go to combine those, This is a perfect example of a problem where
Mm-hmm.
instead of thinking negative 6 plus 10, it's a lot easier just to think 10 minus 6.
Okay.
10 minus 6 gives you the 4. This part here, remember you added in that negative sign there. And that's correct. There's a more simplified way we can write that. Instead of writing 4a plus negative 30. Yep, you got it. They both mean the same thing, but instead of saying plus negative 30, minus 30 is easier. You've got that. This last one, you might see, says, with a partner. Your partners decided they didn't want to come today. But that is okay, because I can talk you through this. I would love to hear your thought process. So the question is, find the missing number that goes in each of these boxes to give you what we're saying is the answer. And then the second part of this is convincing me why you're correct. So this first one here, I'd love to hear just like what you're thinking.
Negative 2.
Where is that coming from?
Because negative 2 times 3 would give you negative 6.
Mm-hmm.
And then negative 2 times 1 would give you negative 2.
All right. So if I wanted you to convince me why you're correct, you could write words, you could write math down. What do you want to write to convince me of this?
Well, 2 times 3 is 6, and you have to use the negative because it's a negative times a, well,
You're right, yeah.
negative times a negative, well, positive
Mhm.
would be a negative,
Mm-hmm.
and negative, and 2 times 1 would be 2, and because it's a negative plus a positive.
Mm-hmm. So you could write down something in words like you were just saying. You could say, I know that a negative times a positive equals a negative. And then I also heard you say negative 2. Oh no. I'm just going to hold them there. Negative 2 times 3x equals
Negative 6x.
and you also
Negative 2 times 1 equals negative 2.
yeah, so something like that. If you you looked over, I'm talking to the camera. If you at home or you in the classroom are more of a word person, you feel like English is your strong suit, you could give me words. If you're like, nah, that's not for me, you could just do the math. So you could literally come over in that blank space and just show me why it's correct. You could say, well, that multiplies to,
Negative 6x.
and then,
Negative 2 times 1 is negative 2.
yep, and then say, hey, look, they're the same. So it's up to you how you want to do it. At the end of the day, they're both saying the same thing, right? You're just showing me that you're correct. This is always good, though. Even if I'm not asking for it, convincing yourself that you're correct is a good way to make sure you've got the right number there. You automatically caught on to we need a negative because of this right here. But I've gotten a lot of 2s in the past. But if you were to multiply that out, you would see, oh, wait, that's not giving me exactly what I want. We did this one together. This one looks even more fun, so I'm going to have you try that. And people at home, this is where I say goodbye.